Hello, Algebra Scholars. This is section 7.3, Systems of Equations and Elimination. It's my favorite method for solving a system of equations. Anytime I have to solve a system in any of the courses I teach, this would be the method that I would use. I think you'll find it to actually be the easiest. It might be a tiny bit more work, but I think it's the easiest, and it makes dealing with fractions quite simple. Here are the 4 steps. Step 1 is to line up the x's, the y's, the constants, and the equal signs. Step 2, multiply one or both equations by a constant so that the coefficients for one of the variables are opposites. We'll see what this means when we do an example. This will make more sense to you. Third step is to add the equations and solve for the remaining variable. There will only be one variable left at this point. And then step 4 is to repeat steps 2 and 3 for the other variable. Let's go to a clean screen and we'll do an example. Okay, Algebra Scholars, here is our first example. I've copied our little algorithm over to the next page here. Hopefully it's not too small. You can still read it. Step 1 says to line up the x's, y's, constants, and equal signs, and that is already done in this problem. The x's are lined up, the y's are lined up, the equal signs are lined up, the constants are lined up. We'll do an example later where that's not the case. Okay, so step 2 is to multiply one or both equations by a constant so that the coefficients for one of the variables are opposites. Okay, so I'm going to start with the y variables. I want these two numbers to be opposites of one another. Now they have opposite signs, but they're not opposite numbers. Remember, opposites are like 3 and -3, or 5 and -5. So I think you would see that if we multiply the top equation by 2, then we would get the coefficients of the y variables to be opposites. So let's do that right here. So we're going to distribute this 2 to this whole equation. I get 6x plus 4y equals 10. The bottom equation I don't need to touch at all. 2x minus 4y equals 1. You'll see now that the coefficients for the y variables are opposites. So step 3 says add the equations and solve for the remaining variable. So we're going to add these equations. We're going to add down. 6x plus 2x is 8x. Now when I try to add the y's together, what you'll notice is I've eliminated them, hence the name of this method. The y's are gone. I carry the equal sign down and I add the 10 and the 1 and I get 11. And check what it says here, solve for the remaining variable. You'll notice the y's are gone. All that I have left now are x's, and to solve for x I just need to divide by 8. So I know that x is equal to 11/8. It's a fractional answer, but I didn't have to deal with fractions anywhere in this problem. Now, we need to go to step 4, which says, okay, let's repeat the second and third steps. So here's what we're going to do now. This time we need to eliminate the x's. I need these coefficients to be opposites. And there's no way to multiply just one of the equations to make them opposites. I'm going to have to multiply both of them. So I need to think about what's the least common multiple of 2 and 3, and hopefully you'll see that it is 6. So I'm going to multiply the top equation by -2, and I'm going to multiply the bottom equation by +3. Let's see what happens. So top equation by -2 gives me -6x minus 4y equals -10. And then the bottom equation by 3 gets me 6x minus 12y equals 3. We will add the equations and we'll see that we've eliminated the x's this time. And when we add the y's, we get -16y equals -7. And when we divide both sides by -16, we get +7/16. So as an ordered pair, our answer is 11/8 and 7/16. Okay, here's a much harder second example to follow. I want to make sure that we deal with step 1 a little bit here, where the x's, y's, constants, and equal signs all need to be lined up. And actually, the only thing that are lined up right now are the constant terms. The equal signs are not, the x's are not, the y's are not. Nothing is directly above or below each other. So let's take a step and let's write it in ax plus by equals c form. So I'm going to move the 2y up here over to the other side of the equation, making it minus 2y. I'm going to leave the equals negative 7. So I moved the y term over. On the next equation, I have to switch the order of the x's and the y's. They're in the wrong order. So I'm going to get, x plus 1/2 y equaling 1. All right, now I can start my method of elimination. But I have a fraction to deal with. I'm going to eliminate the y's first, like I did last time, although it really doesn't matter. So I have a fraction to deal with here. Hopefully you'll see that the least common multiple of negative 2 and 1/2 is actually 2. So I need to turn this 1/2 into a positive 2. And to do that, I need to multiply by 4. Top equation, I'm going to leave alone. 3x minus 2y equals negative 7. Bottom equation becomes 4x, remember 4 times 1/2 is 2, plus 2y equals 4, and when I add the equations, I get 7x, the y's are gone, I bring down my equal sign, and I get negative 3, so x is equal to negative 3 over 7. Now to eliminate the x's, I am not actually going to go back to this equation because it has fractions in it. I'm actually going to go to this equation and now make my coefficients of my x's be opposites. So I'm going to the least common multiple here is 12. So I'm going to multiply the top equation by negative 4 and the bottom equation by 3. And I'll do that over here. Negative 12x plus 8y equals 28. 12x plus 6y equals 12. I'm going to add the equations. The x's are gone. I get 14y equals 40. Divide by 14. I see that I can actually reduce this answer to 20 over 7. So my final answer is actually the ordered pair, negative 3 over 7, 20 over 7. And that's the method of elimination.